First, a quick introduction to Starof for those of you who are joining us for the first time. At Starof, we seek to match people with work more efficiently. We're currently focusing on creating a vibrant community of Java developers where you could find interesting career opportunities, engaging resources to learn new things, and the opportunity to network with experts and seek their help. The main purpose of our webinars is to help developers learn new frameworks and tools that make them more productive at work. We bring great speakers from the tech world to talk about new tools, languages, and frameworks. And today we have Brian Benz. So he joins us from the US. Brian is a senior developer advocate at Microsoft. He helps Java developers get the most out of Azure. If you see the enterprise, Azure is a very popular cloud platform. So a lot of interesting stuff on Azure. So and before joining Microsoft, he was a solution architect, consultant, developer, author, and presenter at IBM, Deloitte, and other companies. Brian is proficient at Java, big data, fast data, and all the JVM languages like Scala, Kotlin, and Groovy. He has a widely followed Twitter profile, Twitter handle, that's at bbenz. On the topic for today, all of us are aware that product development has become rapidly iterative. There's no developer these days who says they don't like DevOps. There was a time when developers sort of resisted the idea of DevOps, but yeah, every project, agile or otherwise, needs a DevOps implementation. And but considering the amount of tools that are available, the kind of hype that DevOps generally generates, it's hard to kind of clear the clutter and understand and make one's way through it. So this session is going to kind of focus on helping Java developers start their DevOps journey and some of the best practices to keep in mind. Generally we'll focus on the people, processes, and tools side to support a DevOps implementation. So Brian will highlight the easiest ways for developers to work with their IT organizations and partners to deliver their code to the cloud, including the best ways to sort of reliably make updates and maintain production code as production releases become more frequent. So the session will take about 55 minutes, and then we'll have like 5 minutes at the end for Q&A. So if you have any questions, feel free to ask them in the chat. We will have Brian answer them for you at the end. So Brian, it's a pleasure to have you on the webinar. Thanks for taking the time out. Let's begin.
Thanks for having me. Yeah, welcome. I think that intro was great. I think we're done, actually. I think that covers everything. So if anyone has any questions, I'm just kidding. No, thanks. That was a great introduction. Yeah, I'll jump into what I'm going to talk about. And it's a meetup. It's casual. So if you have questions as we go, if they're pertinent to what I'm speaking about at the moment, then Shashi, please jump in and let me know. If we're going to cover it later, I'll tell you, but otherwise, yeah, we can answer it there, and we'll have some time at the end to answer questions too. So yeah, as Shashi said, my name is Brian Benz. I'm a cloud advocate at Microsoft. I'm based in Las Vegas, so it's Friday night over here, and it's good to be here. This is my perfect hour. I don't know about you folks, but I'm more of a night owl, so I do work in the evenings anyway. Yeah, this is a great time to be here. So welcome to you across the world. Okay, so yeah, as Shashi mentioned, my Twitter handle is bbenz. Please do follow. And all the things I'm going to show you today, you can find backup materials for it at aka.ms/DevOps for Java shops. All the repos that we have here that I'm going to show, the steps we go through. I'm going to go through some slides really quickly, and then we're going to go straight into demos. And the demo today I'm going to show you is GitHub Actions. So we're going to take a code repo and we're going to publish it to an Azure web app, which is our software as a service, platform as a service on the Azure cloud. And that's going to automatically update every time something gets done. And it's just a really simple Spring Boot app we're going to use, but I'll show you a little bit. It has feature flags built into it. So I'll show you how to implement feature flags as well. So what we're going to cover today is what is DevOps. I'm going to talk about DevOps with GitHub, a little intro and then the demo, and then a way to keep your investments as well. Because a lot of folks out there do have investments in other tools, in tools they've built over the years. People have a crazy amount of bash scripts, or they have a large Jenkins infrastructure with very detailed implementation of builds and tests. And quite often the deployments aren't really there, but we'll talk about that when we get to that part. But I'm going to show you how you can keep all that if you've already invested in it. That's not a problem. And how you can leverage some of the things I'm going to show you here today to work with them as well. So let's start with what is DevOps? This is a great quote from a colleague of mine, Donovan Brown. DevOps is a union of people, process, and products to enable continuous delivery of value. So I've highlighted a few things there: people, process, and products, and value. When you're working with DevOps, for those of you who tried to implement a system, it takes some work. It takes some organization, and it takes some technical effort to actually build an infrastructure that supports a reliable DevOps process. So to do all that, there's no point in investing in that unless it's delivering value, really. So let's start with the first part of that, which is the first part of people, process, and products, which is people. Here's some of the questions you always get asked in every project you've ever worked on. I guarantee it. I'm sure everyone is familiar with these questions. Works on my machine. It works on my machine. I don't know why it's not working in production or in test or whatever. This is not my problem. It's working. Look, I can show you a proof of concept right here on my laptop. Who's supporting what? So not just who's supporting the application, but who's supporting what development stage you're at in a process. Like who's supporting the planning, who's supporting developers, who's supporting testing. Where is my code? Where is my code in terms of where it's physically located or digitally located, but also where is the code in terms of the completeness of it or the stage it's at for the new feature that we're building. Can I get an update? And an update could be a software update or a project update. How's the timeline? So that's the big one all the time. How's the timeline? Where are we at? We promised this new feature, new version of the application on a certain date. And are we going to make it? How far are we away from making that date? What stage are we at in the process? Are there any roadblocks we're encountering as we go along? So these are common questions you get. And the way to actually support people who are working with a software project, a software product, or an organization is through processes. And a good process, of course, is the basic software development lifecycle, where you have the 4 stages: planning, develop and test, release, and monitor and learn. So planning is, of course, we have a new feature, and then the planners have to delegate the task of actually developing that feature and testing it to others and monitor progress. Then you need to have a reliable and secure release process as well. Once it's in production, something that really gets overlooked or neglected is monitoring and learning as well. And that's something that the process needs to support so that people can answer the questions I just showed you in the previous slide. So products. Products is a great way to support the process that supports the people. At Microsoft, we have several products that you can use for this, some free, some paid. Of course, GitHub, Visual Studio is our IDE for non-Java things. We also have Visual Studio Code, which supports Java, and we have extensions that we support for Eclipse and IntelliJ, which, as I'm sure everyone's aware, most Java folks are using those. But Visual Studio Code actually has support for Java through some pretty elaborate and well-designed extensions. So I do suggest checking that out as well. It's a free open source text editor. I'll talk about it a little bit later. But we also have Azure Pipelines, which formerly known as Azure DevOps, for those of you who might have seen it before, GitHub Extensions and GitHub Actions. So there's a slight difference between GitHub Extensions and Actions, and I'll talk about that in a little bit. And then when you're actually managing and securing your applications, we have Azure Monitor for performance and troubleshooting. We have Azure Policy to enforce compliance with any regulations you might have related to your organization. Azure automation for automating those policies and making sure that everything from performance to compliance is being supported in your organization. And then we have the Azure Security Center, which is, we literally spend billions of dollars on security, keeping ahead of the latest threats that are out there. So delivering with Azure, I mentioned a couple of these things, but I definitely want to explain a little bit more detail. So GitHub, we have GitHub Actions, which is a scripting language that you use for a variety of tasks. In this case, we're going to use it for continuous integration, continuous deployment, CI/CD. But we also have GitHub extensions. GitHub extensions are not the same as GitHub Actions. GitHub extensions are actually little pieces of code written by third parties like Microsoft or Google or AWS to help integrate your GitHub repo with tools. You can use GitHub extensions, for example, to connect to Azure pipelines or Azure boards here and integrate with other tools that are outside of the Microsoft sphere of applications. We also have, with GitHub, integration with Azure, of course. It's a purchased by Microsoft a few years ago, so the integration with Azure is pretty good, but it also integrates with other clouds as well. We're all friends here for the purposes of deployment. If you have multi-cloud, we support multi-cloud with that as well through GitHub and GitHub Actions and GitHub extensions. There's integration with popular IDEs. I'm going to show you Visual Studio Code. I'm actually going to show you a new thing called Code Spaces as well, for those of you who might not have seen it. And free private repo. So this is something that when GitHub was purchased by Microsoft, there was a lot of press and a lot of chatter in social media about, what is Microsoft going to do with GitHub? Are they going to try to monetize it? Are we going to see charges for things that previously for free? Actually, it went in the other direction. So originally, when GitHub was purchased by Microsoft, you could have a free public repo, but you had to pay for private repos, and you had to pay for repos with teams. So now we actually have free private repos for individuals and teams. When they get to be a certain size and a certain number of users, there is a charge, but for most projects, they are free. So check that out. If you haven't checked it out lately, it's actually a lot more free stuff than there used to be. And we have Code Spaces. Code Spaces is something I'm going to explain a little bit, but just bookmark that for now. We also have Azure Boards, which is Kanban boards for planning. So I showed you that software development lifecycle, the 4 stages. We have Azure Boards. We have Azure Pipelines for builds and tests. In fact, Azure Pipelines is what GitHub Actions is built on top of. So when GitHub was purchased by Microsoft, once again, we actually transferred most of our Azure DevOps / Azure Pipelines functionality to GitHub because it just made more sense organizationally. And they actually run behind the scenes, everything on the same platform that Azure Pipelines runs on. So I'm going to show you a little detail about that when we get into the demo. We also have Azure Artifacts, which is for artifact storage, and GitHub has their own artifact storage as well. And we have Azure Test Plans. Azure Test Plans are for load testing and website testing and other applications. So I urge you to check that out for sure. So a little bit about GitHub. Most people are familiar with GitHub, but here's a little slide to tell you how popular it is. I like to do something else though. Let me just open up this browser here. Instead of going to that slide, which is out of date every time I save it, I go to the 2021 State of the Octaverse. So this 2021 State of the Octaverse is a cool resource for you anyway, but it's a good way to check a few things out. What happens at GitHub is every year they go out and they take an analysis of all the repos on GitHub. Who's using what? How active are they? What programming languages are popular? And out of that, they keep track of their own metrics for reporting purposes. And let's see, let's go down the Octaverse here. I think it comes out in September every year, so it's still pretty relevant. So 73 million total developers on GitHub as of last year, 16 million new users in 2021. Anyway, a lot of stuff. 170 million pull requests merged, 61 million new repositories in a year. So the point is, I guess it's active. And in North America, it's pretty active. It's down 2.3% from last year in terms of activity in North America. I guess Asia would be qualified as India. They really should make this more specific, but it's not Oceania. We know that's that's going to be Australia and New Zealand, but Asia would be here. I would love to see, as I'm sure my audience would, India broken out in here, because I think that would be a significant difference. But yeah, there's slight increase from last year in activity there. Top languages, I love this one. So if you look here, JavaScript, you could debate whether or not it's a language. I'm sure folks here who are familiar with Java would have some strong opinions on that, as I do. But because they have Node.js and React and things like that, they tend to be in the top spot all the time in terms of popularity of the language. I'm putting my fingers in quotes. And then Python. So something happened around 2018. Python started gaining more popularity than Java, but Java's still pretty popular out there. TypeScript has really increased since. Well, they seem to have, since 2018 as well, really taken off. C#, you get the idea here. So there's a whole bunch of different languages, and you can see the trends that are going on. For the purposes of this presentation, Java is still up there towards the top. There's a whole bunch of other data here, but I just wanted to show you that, and we can go back to the slides. This slide's always out of date, like I said. We have lots of customers. Okay. So GitHub, what is GitHub good for? Of course, it's good for, code repos and storage. And it's also good now that we have actions built into it and a few other things. It's great for scaling and building out your DevOps infrastructure for free, mostly. We use hosted runners, so they run on GitHub. I'll get into that in a little bit of detail, but over on the right, I just wanted to point out that you can deploy to on-prem, Azure, AWS, Google Cloud Platform, or any destination you really want. They're probably, if you can think of an action, it's probably out there. And what these GitHub actions enable is powerful, flexible, continuous integration, continuous deployment. So it's natively integrated with GitHub, and there's different options and ways to do that. I'm going to show you a code space option for this. You have automated workflows with Azure. So you can trigger something. For example, if somebody pushes something or merges a pull request, you can automatically trigger a process that does some testing and maybe a deployment, a testing, building, and maybe a deployment as well. And that can be multi-stage and secure because it's integrated with your repo and with the destination, using these things called published profiles, which I'll show you in a bit as well. And you can use your preferred languages. You saw the languages that are supported. These are all supported here. And also, anything that I'm showing you today runs on Windows, Mac, and Linux. It runs in a browser, and or Visual Studio Code also runs in a browser. So it's the largest DevOps ecosystem on Earth just by default because we have the largest set of repos on Earth. But we also have any kind of crazy idea you have for building your own GitHub action, check with the GitHub Marketplace. Just search for GitHub Marketplace and look in there, do a search for, here's one for Jenkins file. So for Jenkins file runner, Haskell, linter. I mean, there's all kinds of things in there that you might not have thought about that can be used to work with this. And specifically for the Java audience, I know Jenkins is very popular. I work with it myself. I work with Kazuki Kawaguchi, the creator of Jenkins. He's now at a startup called Launchable. If you check that out, that's a pretty cool startup. What they're doing is they're implementing different ways to test and deploy with AI. So they're basically encapsulating best practices, not just can we run this script, but best practices for different types of applications into a test and deployment platform using artificial intelligence. So there's my little ad for KK. It's a startup, and they would appreciate it if you check it out. It's pretty cool stuff. But yeah, we don't have any support or link with them. I'm a fan of his products, and of course Jenkins and other things. So so yeah, and you can bring community standards into your integration as well. There's a lot of compliance and integration tools that you can use built into these actions as well. All right, so GitHub Mobile, people don't know about this. There is a GitHub Mobile app. So if you're doing a lot of work on GitHub, you can't do everything, but you can do things like, review a pull request, create an issue, merge pull requests, push something to, that kind of thing. Anything that you can do on a repo, you can do it through the GitHub mobile app, which is kind of handy if you're busy and you're not always in front of the laptop. I personally have used it before to disable workflows for actions, for example, when I'm on vacation or something and I'm not close to my laptop. All right, so code spaces. I keep mentioning it and saying I'm going to tell you about it later. Here it is. So code spaces is a way to implement a IDE, in this case, Visual Studio Code, in a browser inside your repo. So what if you go to a repo in GitHub and you just want to run the code? So you can click the code spaces button, create a new code space. It will actually create a clone of that repo. It doesn't edit directly into the repo because that would be bad practice in case other people are collaborating on that repo. But it does create a clone of the repo and open it in an integrated development environment that has most of Visual Studio Code's features inside a browser, any browser. So that's pretty cool. And then you can run it, you can test it, you can push things back to the repo and trigger actions, which is what the demo is I'm going to show you today. So you can really simplify your workflow as well. And you can create custom-made code spaces. So you can have a pre-configured code space that has all the tools and extensions that you need built into it. And any compliance and any, if you need a minimum version of Node or a minimum version of Java or something like that, that can all be pre-built and pre-configured into a code space. And then you can control who gets to run which code space as well. So if someone runs a code space, you can just open it up and everyone has the basic stuff, or you can create a pre-configured code space that they have to use when they're working with your repo, which is pretty cool. So if you combine that with a private repo, for example, you've got a pretty secure and flexible coding infrastructure. You know that no one's going to be able to do anything, or they're not going to be able to, by default, do anything that you wouldn't expect them to because everything's pre-configured for them. All right, enough talk. So let's go into the demo. So the demo I'm going to show you today, I'll show you the application first. Let me see here. Okay. I'm going to close the State of the Octoverse. So we've got an application. It's here. It's just a Spring Boot application. And I'm just going to refresh it. And it's just a Git. So this is our developer advocate mascot named Bit. And he is the feature that we're using for our application today with feature flags. So what's a feature flag? So a feature flag is, for example, if I go into this feature flag manager, and I'll explain what this is in a little bit. I'm just going to show you the demo first. And this beta feature in here is enabled right now. If I disable this feature, I go back to my application, and I might have to refresh it once or twice. Usually I do. There we go. So Bit's gone. So the feature is Bit. That's I mentioned that before. The feature's Bit, and basically it's controlled through this beta feature. So it's kind of a silly little demo, but imagine if you had a new product or service or something on your website and you wanted to, trying to refresh this a couple of times. Sometimes it takes a couple of minutes to restart the actual feature. I'll come back to it. But imagine if you had a new feature that you want to show, or you want to show this feature just to some of the people who visit your website. So that's called A/B testing. You can turn that on and off through a feature manager, and you can have multiple feature flags here. you can also have one feature flag that is controlling many applications. There's also a way to set it up so that the feature flag is only enabled for a certain period of time, or as I mentioned before, a certain set of users who come in. For example, if I add one here, and I'll call this feature flag star of Java. Okay. And then I say use feature filter. So there's targeting. So targeting means you're going to target specific groups by geography, by server group, things like that. And then you've got a time window, as I mentioned before, so you can set up a time window. So it's going to start on a certain date and end at a certain date. So you have a holiday or something like that, and you want to display something on the website saying things are going to be different, you can actually do that here. Or if you have maintenance or updates. Or if you want to avoid having warnings of maintenance and updates, you can do custom, and you could do percentage, and you can say 50%. And what that will do is only half the people who come to the site will see this version of the site, and with the new feature in it. So that can be used for A/B testing, which is half the people see the new feature, half the people don't. You can track the behavior of the people seeing the new feature to see if it delivers the results you're expecting. You can also use this for blue-green deployments. So you could theoretically increase this. You could have start out at 30, and then go to 50, and then go to 70% of the people, 80% of the people. So you could slowly roll this out to people that way, just by changing the percentage and checking out, is anything being disrupted when I deploy this? There's one other way to do blue-green deployments using Azure App Service, which I'm going to show you after this as well. But that is something, theoretically you could do as well. So that's feature flags in a nutshell. And by now this thing should be refreshed because I enabled it. There you go, bits back. There we go. Takes a second sometimes. Okay, so that's the idea behind the feature flags. So let's talk about how we actually got here and how we actually built this. And I'm going to build one from scratch for you. I'm going to build that website from scratch from the repo that I have code in it. And we're going to edit that code with code spaces. And the other thing I'm going to show you is how to set up the feature flag. What I like about this demo is that it's not a hello world demo where everything's standalone, because when in the real world, you never deploy an application that just sits there by itself. It's usually connected to something else. So in this case, it's connected to the feature manager. And we have a connection string that connects the application to the feature manager. By the way, if I'm running it locally or anywhere on-prem, it's always connected back to that feature. There's a segment of code that goes into your application that wraps around the feature, and it checks the feature manager before it actually decides whether or not to display that code. So that's how that works. But the cool thing is it's just like the central location where you can turn it on and off. Anyway, that's that. All right, so let's go into what this application is. So this application is an Azure web app. It runs on Azure. This is my Azure portal. So I have a dashboard that I set up. I set up custom dashboards for everything I do. Over here, I've got the links I want to show you today. Over here, I've got the actual apps running. So the app that we're just looking at is called DevOps for Java Shops, and that's this app service. There is a configuration in here. The configuration itself has the connection string. The connection string points to, let me zoom in a little bit on this. The connection string points to the actual feature manager that controls the application, and it won't run without a connection to that feature manager. It also won't build if it doesn't have the connection to that feature manager. So bookmark that idea, because I'm going to show you what happens when in the real world when you try to deploy an app that isn't connected to something that it needs to be connected to. All right, so basically, this is my dashboard. Like I said, this is a group. In the square here is what you call a resource group. So all of these resources are grouped together in a resource group. And my Java app service plan is how you actually control how fast and how much money you're spending on your web app, basically. If I go into Java shops here, I can go here and I can go to scale up. And this, I just did this before we started because I gave it a crazy fast app server. Otherwise it goes kind of slow and it makes for boring demos. So this particular one we're using has a virtual CPUs, 32 gigs of memory, 8 virtual CPUs, and it's about $200 a month. When I'm not using it, I scale it down to this $31 a month demo, just because I get pings from the Azure group if I don't. So you get the idea here. You can scale up an app service, and you can also scale out an app service. So that's kind of some cool features here. I can do a custom auto scale. So for example, down here, if I have over 75% of my virtual CPU being used, kick out another virtual CPU up to the maximum of, however many I want to mention here. And the default, you can set up a default too. So you can have minimum, maximum defaults. And when the CPU percentage, here it says it right here, when the CPU percentage is above 70%, it'll add a new one. When it goes down, I believe under 35%, it's going to remove the extra CPUs as well. So you don't pay for them, because you do pay for each instance. But that's the kind of idea. So it makes it really easy to scale this up. It was literally about 30 seconds to scale this up before I started running the demo today. So, for those of you who might have been around for a while, that's pretty impressive stuff when you remember you had to go out and get servers and make sure they had all the capacity you needed for bursts and all that stuff. This is pretty cool stuff now. So the idea here is you've got a app service plan, then you've got a bunch of app services. So these are the individual websites. And those websites, can do anything you want, in this case, Java. So what we're going to do is we're actually going to create a new website here. And then it's automatically going to generate a GitHub action for us. And that GitHub action will do a deployment to Azure, but it's going to fail the first time because we don't have the connection string in it. And then it's going to go to the new app. It's going to deploy. Everything's going to be fine, but it's going to fail too because the new connection string is not in the application. So let me show you all that and what you have to go through to basically deploy this in the real world using CI/CD. And by the way, once you get all that set up, all the connections set up, any changes you have, if you push them to the repo, are automatically published back out to the web app within reason. Okay, so we're going to create a resource here, and we're going to create a web app. Web app itself, it's my subscription. I mentioned the resource group. So the resource group we have here is called DevOps for Java Shops. And I'm going to call this one Star Java App. How's that? See if it's okay. Yep, the little check mark there means that is okay. Let me zoom in there so you can see it a little better. So starofjavaapp.azurewebsites.net is available. So I get the little check mark there. I can run code, Docker container, or a static web app. My blog at brianvince.com is a Hugo app. It's pretty cool. I use a static web app for that. But you've got a choice for your runtime of .NET, Java, Node, Python, PHP, and Ruby. We're going to go with Java 11. Java 17 was just released last week, by the way, so we have support for Java 17 now. And you've got an option of the operating system be Linux or Windows, and then a region. Now, the region, you can put it anywhere you want. As you can see here, these are all the locations we have. They're called regions. There's 60 of them right now, I think, or maybe more. They're called regions because there's not actually physically a location. Could be multiple, between 2 and 10 actual buildings where things are in the area that's mentioned here. So they call it a region. I still mention location just because it's easier. But I know that my web app plan that I already have built up is in West US 2. So we're actually going to use that for this. And it automatically tells you what your Linux plan will be for West US 2 because it knows it's in that location. If I pick UK South, it doesn't have anything, right? There's nothing there. So it asks me if I want to create a new one, but I want to use the one we have already because it saves a little time. Next, deployment. So here I can enable deployment. And now I've got to enter some info about the repo. So when you enable deployment from here, it says, okay, so you're going to deploy this from a repo. And you can, in this automated system deploys from GitHub, but there are others that can deploy from GitLab or Bitbucket and things like that. You have to write custom YAML for that. But for this one, it's just easier if I go through and I use the GitHub repo I already have set up. So in this case, it's in bbens. Actually, let me show you that repo real quick. It's over here. It's called bbens DevOps for Java Shops test feature flags. And what we're going to do is this is going to generate some YAML. It's going to push this up here. As you can see, there's no YAML now, but you have all kinds of things you can do to pre-build your YAML. But we're going to use the automated YAML that gets generated by the app service deployment process. And you can see here in the code, there usually is something called workflows up here, and that's where the actual code for your action is stored. And then inside actions will be the actual actions running. So right now it's just blank because I deleted everything. And we're going to start from scratch there. So let's go back here. There we are. So I'm picking bbens as my organization, and we're going to use DevOps for Java Shops test feature flags. That's the one we want. Okay, and we're going to use the main branch. That's the only one I have. Okay, so you can preview the YAML, but I'm not going to. I can also do networking here. There's a way to do a reverse proxy, but it's in preview right now. I'm just going to skip that for now because we're doing a simple demo. And then enable application insights. So this is Azure Monitor. This is the part of Azure Monitor that I mentioned before for managing performance compliance. There's no need for this today because the demo app doesn't need to be probed for compliance or performance. It's a really simple little app. So we're going to do review and create, and then it's going to create. So right now what it did is it generated that YAML file for me, and it's actually pushing this right now up to the repo. And then at the same time, it's actually creating a new resource for me in my resource group, which is the web app. And it's using that app service plan as the trigger for what size of web app and things like this that we should be, what size of web app platform we should be running on. Remember the 32, the virtual CPUs and the 32 gigs of RAM and all that is all predetermined by that app service plan. And it's going to tell me that it succeeded, but it's a complete lie. It's not telling me the truth. You see, it said deployment succeeded. Your deployment is complete. That's more accurate. So I can go to the resource here, and I can show you the overview. Go here. At starofjavaapp.azurewebsites.net, and it just says, hey, Java developers. There's nothing there. If there's another little cool tool you can use here, something called Kudu, starofjavaapp.scm.azurewebsites.net. What this does is it logs in, checks my credentials, and then it gives you a insight into the environment. So it's a SaaS environment. You don't have a control over everything, but you do have control over quite a bit, and you can probe and check out a bunch of things and see why it's not working. So in this case, we use the Java SE built-in server, and I want to see what's in www root, which is where our jar file should be when it gets deployed. And as you can see here, it's not there. It's just this hosting start HTML page, which shows you the application itself. So that's not very useful. It shows you that little welcome Java developers page. All right. So what do we want to do? We want to actually fix this. We want to have an app.jar in here. So let's go into our GitHub repo, and I can show you in the action itself. Now there's an actual action here instead of that little getting started screen. And as you can see here, it didn't succeed. So if we drill into this, you'll see that the build failed, and you'll see that the build with Maven part of it failed. And without getting into too much detail here, it's kind of slow to show us everything anyway, but the build with Maven basically didn't succeed because it requires that link to the feature manager. It actually needs that connection string to the feature manager to make the build happen, because it kind of wants to build the application as if it was in production. So that's a dependency, and it's not here. So how do you actually fix that? In the code itself, I mentioned there was this directory wasn't there before. So GitHub, so this is the YAML that we have. And the YAML itself basically looks like everything should work. Now, we need that connection string. Do we want to put the connection string in the GitHub repo for everybody to use? Yes. But do we want to give everyone access to it? And the answer to that is no, because this is only for people who are building applications and deploying them. We don't necessarily want them to have access to that connection string, because if they do, they could get in there and potentially turn on and off the features and wreak havoc in our system. So that would be bad security. So the way to set that up is in settings, there are secrets. So in secrets, there's secrets for actions, code spaces, and other things. So as you can see here, this is a connection string that I have that's in here. It's only available to owners of the repo, and it's already pre-built with the connection string to the feature manager. But it's not in that YAML, right? Because that was automatically generated YAML. So it's just not there. And there's also this thing called a published profile. This published profile was just updated 3 minutes ago. This is the token that connects your GitHub repo to your app service. So you securely deploy. So not anyone in the world can get into your app service and deploy whatever they want. And not anyone in the world can connect from your GitHub repo to the app service. You have to use this token. So if we go back to the code itself, you'll see that GitHub workflows, there it is. The YAML file has a reference to that published profile here, but it doesn't have a reference to the connection string. So I actually created something handy for you if you ever want to follow along with this. You'll have to create your own feature manager and then create a connection string. Call it the same as I call it in the demo. And I've got a provided GitHub workflow file here. And the provided GitHub workflow actually contains the reference you need in your YAML file. So this is the reference you need in your YAML file to make that work. All right. So let's go back to, so to edit this, right? We don't want to just edit it here. I could just edit it right here, but that's bad practice, right? Because then you're going to have all kinds of, or you can have potential merge conflicts and things like that. You don't want to just edit straight in the repo because multiple people might be accessing it. So to do that, we have something that I mentioned before, code spaces. So if I go here into code and I go to code spaces, pardon me, let me get some water here. I can create a new code space right from here, and I can add that envar reference. So let's do that, create a code space on main. And what this does is it actually creates a repo in a container that's running on something called a hosted runner. I'm going to explain what the hosted runners are once we get all this working. And I'll show you a little bit of that as well. So this is the browser window over here. You can see the other browser windows. This is the browser window with the little icon there for editing the code. And this is our code. So if we look in here, GitHub, there's the main Starof Java app. Because it's a browser, I can just zoom in. Just under the name, we want to put that reference to the envar. And you can see here that everything is color-coded, and you've got some basic autocomplete, and you can add extensions. This is a great example right here. So down here it says extension pack for Java extension is recommended for this repository. Do you want to install it? And I could install it here, even though this is a browser. Now, I mentioned before that you can create pre-configured code spaces. This is what you would do. It's a JSON file that you pre-configure in here, and you tell it, I want to use this configuration for anyone who opens a code space on my repo. And in that case, you could install the extension pack for Java. You could also add any compliance tools or anything else that you need, working in your organization, forcing them to use a certain version of Java, things like that. But a simple example is, obviously this is a Java application. Do you want to have them using the extension pack for Java every time they open this repo? And that would be a good thing. So I could actually create this and then save it as a pre-configured thing. But for now, I'm just going to keep this as it is because we're not actually editing any Java. We're just editing the YAML file. So you just do Control S to save it. And over here on the left, for those of you who used Visual Studio Code, this is the code control, the source control tab. And when you go into the source control tab, it shows that this file has been changed because remember, this is a clone of the repo. We're not in the actual repo, and you do have to push just like you would anywhere else. So let's just say update YAML with feature. Okay, and let's get that L right. All right, and then what I can do is just check this checkbox, and it's going to tell me there's no stages to commit. You know, I can do a stage manually, but I like to just do it this way. Just say, yeah, sure, commit my stage this. And once it's staged and committed, then you just hit sync, and it's going to go ahead and it's going to push to that repo. And let's ask later for the git fetch. So it just pushed this to the repo. So we're not in the repo, remember. This is the repo. This is the code space. So the code space is now up to date with this. But now we have a new action triggered, and the action is actually going to generate, oh, I said feature flag. Anyway, so it's actually going to post to that repo now. It's actually, I already know this, I've done it a couple of times, so I know that it's actually going to build and it's going to deploy now. While it's building and deploying, I mentioned before hosted runners. Let me show you what those are. So hosted runners are over here. About GitHub hosted runners. So GitHub hosted runners are actually, they're running on Microsoft Azure virtual machines on a standard DS2 V2 machine for those of you who are into that kind of thing. Basically, they're available. We've got a huge pool of those available. Anytime you trigger a code space or a GitHub action, it actually goes out and grabs a runner that's running on these virtual machines and builds a container, depending on your configuration, and then runs that stuff. So what's in those runners? Let's go in and look. Hosted runner environments. So the hosted runner environments are actually here. They're pre-built, and the one I'm using is the Ubuntu 2004, the Ubuntu latest stable release. You can see in here what the software is that it's using. So it's got an unbelievable amount of software, an unbelievable amount of tools already pre-built. Now, and it's got Java. If you're not, and it's the exact, it'll tell you the exact version and the environments and everything that you're using for these. If you need another version of something, you can actually add it into your runner through YAML as well. So you can add anything you need. But as you can see here, there's just a ton of stuff here already pre-built into these runners. So most cases are already handled for that. And there's Ubuntu, Mac OS, Windows, 2016, 19, and 2022. So those are the runners we have, so we can emulate those environments. So let's go back to that repo. Let's see where we're at. Hey, there we go. So the feature flag string update, oh well, it worked this time. So we got the green check mark for build, and the build succeeded. It went through and it actually checked out. It actually uploaded the artifact for deployment. And then if we go into deployment, it picked up that artifact from the build and it deployed it to the Azure web app. So if we look at the Azure web app now, let's go back out there. So the Starof Java app, as you recall, it looked like, well, let's go in and look at it. Actually, it's probably easier. So now it's got an error message, but it's still an error message because we haven't set up a connection string for the app service yet. So application error. So let's go into the actual Kudu environment now, that scm.azurewebsites.net. There's the jar. So instead of an HTML file now, we have an app jar file. And you could download this and run it if you wanted to, but you need to set up the environment variable for the connection string. So to set this up in Azure, what we do is we go into, let's go back here. There's the Starof Java app. No, don't do that to me. It wasn't quite the link wasn't set up. I didn't refresh it, I guess. I don't know. Starof Java app service. Okay. So if I go in here to my configuration, remember the last configuration I showed you, it had an environment variable here. This one doesn't have it. So we need to set up the app configuration connection string. And I happen to have it right over here because I'm ready for such occasions. And I say, okay. And now I have to save it, which I always forget to do. Now the actual app will work. We're going to get a different error message this time because I'm not in the right directory, but in a second here, it should be operational. So that's the one that we showed at the beginning. This is the one that we just updated. Yeah, so now we get the white label error page. Now if I do /welcome, we see bit, yay. Now I can go to the feature manager and I can just turn this off. And it's going to turn it off not only for this one that we just generated, there we go. And then it's going to turn off the one for the original one that we showed you as well, because it controls, it basically round trips to the same server. Come on, Star, there it goes. So, so you get the idea here. You can create a feature flag. You can do the blue-green deployments, and you can set that up to work with that as well. Now, I mentioned one last thing, which was blue-green deployments through an app service. So to do that, you can use deployment slots. So this is for blue-green deployments. You can do this for A/B testing as well, but this is actually perfect for blue-green deployments as well. So you create something called a deployment slot, and you say new version. And then what you do in your YAML file for the deployment, and actually we didn't really ever look at that YAML file. Let's go in there and look at that. Okay. Let's go back and let's look at the code for this. So the GitHub workflow that we've got here, I showed you how to update it, but I didn't really show you what the app does. So on any push to this repo, it'll automatically use that Ubuntu runner. It'll check out the code, create a clone of it in that runner. It uses Java version 11. It builds with Maven using Maven clean install command. And then it uploads that artifact. The artifact is app.jar. And then the deployment goes and grabs that artifact from app.jar. And it deploys out to production, and it deploys out to this connection string token that's in your secrets. And it uses this secret to test out the application using the connection string when you're actually building it. So that's what the repo does. So you could actually change that YAML a little bit to deploy to this Starof Java app new version deployment slot. And then you could slowly, you get the idea here, 30, 40, 50, et cetera, et cetera. You could actually deploy out that way as well. So it gives you a different way to deploy your blue-green deployments without disrupting things. You can also do a swap here. So you can swap from what's in production now to the new version here, test it out. And if something goes wrong for whatever reason, you can hit the swap button again and put it back the other way. So it'll actually swap the new version with the old version just by hitting the swap button. So those are kind of cool things. And those are all totally transparent to the user. The user would never know that the application itself was shut down and start up. And that's supported across all of the scaling too. So it might be scaling up while it's doing all this, but that's all supported by each individual server as well for the deployment slots. So that's kind of cool stuff. All right. So I did want to show you one last thing. I promised to talk to you about how you keep your investments. So the investments themselves, this is the software development lifecycle that we had. These are tools that you're familiar with already. You can still use all of these tools when you work with GitHub or Azure pipelines. They all work with this. So the standard workflow for most Java shops is create a Java application, build it in Jenkins, test it in Jenkins. You might have 100,000 tests that you're using in Jenkins already. No problem. You can actually deploy things from GitHub. You can have a trigger. Instead of a trigger on push, you can have a trigger which actually sets up a GitHub action that on a successful build in Jenkins deploys to your Azure app service or a Kubernetes cluster or whatever else you're using, AWS application server, whatever you're using at all, it will use that for deployment. So the cool thing about that is most folks are a little, they've got the build and they've got the test down, but actually the deployment is a little bit sketchy. It's not necessarily 100% secure. Quite often it's dropping something into a directory and a bash script will pick it up eventually through a timer or something. But this way is a way of actually automating everything so that if there's a successful build and a test in Jenkins, it will actually trigger a GitHub action or an Azure pipeline that deploys it out securely, integrated with the environment you've already built with those tokens I showed you for publishing profiles and things like that. So a little example I can show you of that. And I know we're getting running down on time, but I did want to show you this real quick. In the dashboard, Visual Studio Code, for those of you who are familiar with it, is open source. Oops, I hope it doesn't ask me to authenticate. No, good. So VS Code, sometimes it asks me to go through these steps you don't want to know. It's okay, but not in a presentation. So, there's 5,000 issues here. There's quite a few. And there's a lot of pull requests as well. There's 11,543 closed pull requests. But you can actually go in here and you can see Visual Studio Code's actions. So they have actions that have actually been published. Actions. Oh, they didn't change this, did they? Workflow. Code. GitHub. There it is. Sorry. Blah, blah, blah. Maybe they do. They've changed the structure here. I was going to show you their workflows. But you can see some of the actions that are working here as well. I'm not sure where they put the code there now, but the actions are working. So you can see whenever something gets pushed, for example, you can look at the results of this, but you can't obviously access them or control them in any way. So you can see what happens here. For example, only allow primitive values and context keys. They're testing things. They're making things work. And that's all built into Visual Studio Code. So you can go, if you want to see a really robust project and how it all works, the things I just showed you in a really simple example, you can see in VS Code in a real world application with thousands of or hundreds of thousands of millions of users and hundreds of developers all working on a repo at once and triggering actions and doing all kinds of things. So, all right. So that's keeping your investments. And so I talked about what is DevOps. DevOps is GitHub. Showed you the long demo and showed you how you can keep your investments. And don't forget, you can find more info at DevOps for Java Shops. I'll take some questions if there are any. Don't be shy now.
Yeah, thanks a lot, Brian. A very interesting session. Really loved demos around the code spaces and the whole integration with the tools that's available. That's really interesting. So I've got some questions that fall to me. In the interest of time, I'll just ask one. So if we have more than, so this question is from Ashish. So what he wants to know is if more than one developer is working on code spaces on a single project, let's say, and if they're making edits to the same file, so is the versioning and tracking and all that handled online?
Yes. So the question is really, how do they handle merge conflicts and anything?
Right.
People. So when you create this code space, which is what we're looking at right now, this is actually a clone. So if I go back into my repo now, I can see, let me see here, test feature flags, code spaces. This is the one that just got created. It's called potential system. As you can tell, it's a Docker container. It's got that naming system with the randomly generated words. And you can go in and you can share these code spaces. But mostly to avoid merge conflicts and issues like that, everyone would create their own code space, and it grabs the latest version of the code from the repo, puts it in that container, and then gives you a container with the IDE to work with. So when you're working with the code, it's almost as if you're working locally on a cloned repo. It's just a clone that's running on a container on GitHub with pre-configured settings and things like that. So, so that's how you avoid any conflicts, is when you change anything. When I change anything in here, I still have to push back to my original repo, just like you would if you're working locally. So that's how they manage versioning and code and merge conflicts and things like that.
Got it. Yeah. So thanks a lot, Brian, for your time. Very interesting session. And for the people on the call, version of this webinar will be available as a recording on our social media pages. Brian, that's a pleasure, to have you with us today, and we'll try and get you for another session sometime soon.
Sure, I can show you a similar session with Azure pipelines. This one focuses on GitHub, but we could work on pipelines, or maybe even roll some Jenkins into it. But whatever you like to see. So, give me some feedback. Let me know what you're looking for, and we can for the audience. Give me some feedback. Let me know what you're looking for, and we can put together a session. Yeah.
Sure. Thanks a lot. Have a good evening and have a great weekend ahead.
All right. Well, thank you. Thanks.
Thank you.
We'll see.
Yeah. Bye-bye.